My name is Ross Houston. I work for Benchmark Genetics. Benchmark Genetics is an aquaculture breeding company. We breed genetically improved Atlantic salmon from breeding programs in Norway, Iceland and Chile. And we also breed white-leg shrimp from our breeding nucleus, which is in Colombia, and supply to sort of global markets from these breeding programs. And we're also doing genetic services to support clients in the aquaculture industry to improve their stocks via consultancy and provision of genetic services. Yeah. So previously I was involved as one of the work package leaders of AQUA FAANG. I was initially one of the work package leaders for work package 5, which is the work package that deals with the application of the functional annotation data towards QTL and selective breeding. And we were involved in a really nice experiment together with Luca Bargeloni and his team at University of Padova, where we were mapping or working with European sea bass populations to map a major QTL for resistance to a viral disease called VNN. And I was really pleased to see today the sort of final results, that it's really been well characterized, and we have an idea of which genes are actually underlying the disease resistance QTL. So it's nice to see that process progress nicely towards an endpoint. The results are going to be very useful for the future of research and also for the industry in the longer term. I believe one of the biggest contributions to the project is really the resources that have been generated for the different species, the improved reference genomes, the improved annotation of those genomes, the tools and methods that have been developed throughout the project to make it easier for other researchers in the future, whether academic or industry, to work with these species. And I think the applications are going to be, there could be applications when people are ready to implement gene editing, for example, because we know a lot more about where a particular edit could impact on, for example, a regulation of a gene, or it could impact directly on the gene function. And these are, so I see that the genomic tools have wide-ranging implications. Maybe some of these are in the longer term. And there may be also some implications from some of the more immediate tools that have been generated to assist with the selective breeding. I'd say particularly for some of the Mediterranean species, for example, with some of these new tools that could aid with selective breeding as well. So I think there's a lot still to be done on improving selective breeding using, let's say, standard technologies, which are recording the phenotypes on the siblings, for example, of the selection candidates. I think technology to record those phenotypes is one area. Recording these phenotypes in field environments, I think that's very important. I think technologies that would, or methods that would avoid having to do as much testing on the animals, like if we could do assays that could proxy for disease resistance, for example, that's one really important area. I think also developing the methods for making, as we look to the future, making animals have sterility is one important area, and also then the gene editing methods need development to be implemented at a scale that could be possible in commercial production. Even though that's not for now, it needs to be developed so that when the time comes and a gene-edited resistant fish, for example, is ready, then it has the potential to be commercially implemented to benefit the industry.